Okay, let's jump right into this technical specification for Project Chimera's self-auditing defense system.
Right.
This document lays out the whole security architecture. It details the Ares sandbox, the Achilles vulnerability engine, and the Chimera Covenant for ethics.
It's definitely impressive stuff, very technically rigorous.
Absolutely. But we need to make sure the structure really serves that rigor effectively.
Okay.
So first point, to really maximize reader comprehension and flow, the material should probably transition from being quite definition-heavy, lots of repetition, towards more of an outcome-based narrative.
Mm-hmm.
Basically, assuming the reader already has a decent baseline understanding of the core bits.
Yeah, I completely agree. When you're dealing with something this complex, you can definitely risk sort of technical fatigue in the reader.
Exactly.
And the weakness we spotted is that the foundational facts, key concepts like the hybrid approach, fuzzing, symbolic execution,
Mm-hmm.
the three-step closed-loop system, Achilles, Vulcan, Hephaestus, even things like the hardware data diode, they get defined almost every single time they pop up in a new section.
Right.
And for an audience that's, well, presumably deeply familiar with how this system works, which you'd expect for a spec like this, that constant need to redefine things, it just feels like noise, doesn't it?
It really does. It kind of dilutes the impact of the genuinely advanced information you're trying to get across. That's a critical point. I mean, if the reader has to skim through like 5 different definitions of symbolic execution just to get to the interesting new part, the custom core you built, you're losing them. You lose that momentum.
Yeah, you do. So the suggestion for improvement here is pretty straightforward, really.
Okay?
Consolidate all that definitional stuff. Maybe put it in a single high-level summary, perhaps an appendix or a clearly marked reference page right at the start.
Mm-hmm. Makes sense.
And then focus the rest of the discussion purely on the unique strategic advantage or the governance or the specific orchestration of each component. Assume they know what fuzzing is,
Right.
but they don't know how you are strategically guiding it in this system. That's the key.
Okay, so let's think about concrete examples. For instance, in the sections talking about the Achilles LEM module,
Yeah?
minimize repeating the basic definitions. Just cut right to the chase. Focus the text immediately on the novel aspects.
Right. Like, tell us about the strategic orchestration that guides the fuzzer. How does it find new areas? Or the function of the enhanced tracer core. That's where the real value add is.
Exactly. And similarly for that closed-loop system Achilles, Vulcan, Hephaestus, stop relisting step 1, step 2, step 3 over and over again in different places.
Yes. Maybe integrate the 3 components into one central diagram. Or a reference table early on, something visual and consolidated.
Good idea.
Then the later sections can just refer to the components by name, right? And the focus shifts to the integration points, the data exchange between them.
Showing the flow.
Exactly. Showing how the data actually moves from discovery through to the patch. That's much more compelling than just saying, Vulcan is step 2 and it does X again and again.
Okay, that definitely clears up the structural refinement. Makes a lot of sense. But if the structure gets tightened up, we also need to make sure the technical claims themselves hold up consistently. Where did you feel the content started to get a bit uneven?
Well, it happens right around that transition. You go from discovery, which is Achilles, into the repair part of the loop.
Okay.
The Achilles section is frankly dense and very impressive. But the rest of the loop, it doesn't quite maintain that same level of technical detail.
Right. And that leads us straight into our second major critique point, then. The claim of an advanced closed-loop system really needs, bolstering. You need more methodological detail, more significance, particularly for the exploit generation and the automated patching parts.
Yeah.
It needs to match that deep specificity you already provide for the Achilles Discovery module.
We sometimes call this technical asymmetry. The material gives you rich, state-of-the-art detail on how Achilles finds vulnerabilities. You mention specific tools like Angular, AFL++. You explain the hybrid fuzzing approach.
You've really proven the discovery engine part.
Exactly. But then, the next tools in the loop, Vulcan for exploit generation and Hephaestus for automated patching, or APR. They're described mostly by their function and, importantly, their ethical constraints, not so much the how.
So that lack of detail about, say, how Vulcan actually develops a proof of concept exploit or what specific APR techniques Hephaestus uses,
It leaves those really advanced steps feeling a bit, well, conceptual.
Yeah, more conceptual than fully automated, and like proven in the same way Achilles is.
If the closed loop is genuinely automated, the level of complexity described needs to be consistent right through.
Right now, it feels heavily front-loaded. All the deep tech is in discovery.
Okay, so the suggestion here is to apply that same rigor across all three stages.
Precisely. We suggest introducing a higher level of detail about the specific technical challenges and, crucially, the solutions you've implemented for exploit generation and automated repair.
Mm-hmm.
This would fully validate that automated closed-loop concept. You need to show why this isn't just a discovery engine with some high-level ideas about repair tacked on.
Let's make that concrete. Take Vulkan, the exploit generator. The spec mentions encrypting the exploit code. That's necessary, definitely an important ethical control.
Absolutely essential.
But for a technical specification, we need more context. Detail the specific technological safeguard that goes beyond just saying encryption.
Yeah, this is where you can really shine a light on the clever parts of the system.
Okay?
Elaborate on the function of that research IL public key. Explain the process of automatic encryption and storage of the exploit code directly onto the IL.
Ah, okay.
That level of specificity, tying the security mechanism directly to your internal asset ledger, is a really powerful detail. It reinforces both the technical process and that built-in, non-negotiable ethical commitment.
Okay, that makes sense. And the same principle applies to Hephaestus the Patcher?
Exactly. We can't just mention automated program repair, APR, as, a field of study.
Needs more how.
Right. The suggestion is to add a few specific, maybe high-level examples, but examples nonetheless of the type of APR techniques being used.
Such as?
Well, for instance, is Hephaestus synthesizing fixes based on crash path data? That's computationally intensive, has certain implications. Or is it perhaps applying learned fix patterns, maybe using machine learning?
Ah, that distinction matters.
It's critical. Giving us that kind of technical nuance justifies why Hephaestus is an advanced component. And, more importantly, it validates the potential speed and reliability of your automated patch cycle. Makes the whole loop feel more real.
Got it. Okay, so that covers the loop itself. Now let's zoom out a bit to the overall containment, the Era sandbox.
Right. The environment.
The material makes a fantastic case for external protection. I mean, the physical air gap, the data diode, neutralizing covert channels, it's clearly built like a fortress against the outside world. Very strong there.
It absolutely is, which paradoxically makes the final remaining threat vector even more important to address explicitly.
The insider?
Exactly. For an air-gapped Tier 0 environment like this, the threat model has to be explicitly robust against the main remaining vector, physical or operational compromise by authorized personnel.
Mm-hmm.
And you need to formally link the internal safeguards you do have directly to mitigating that insider threat.
So the weakness here isn't the external defense. That's solid. It's that by eliminating external threats so effectively, the primary risk shifts entirely. It becomes an insider. An authenticated operator with physical access, operational knowledge.
The person with the keys to the kingdom, essentially.
Right. And while the document mentions the Chimera Covenant and various tool constraints are listed,
Yeah?
it doesn't explicitly frame these technical controls, things like whitelist-based targeting, the tracer core, secure egress, as the final line of defense against that trusted operator potentially misusing the system.
If you've locked the front door, the back door, and all the windows, you need to talk about who's already inside the house. The documentation needs to reflect that gravity, that shift in focus.
Okay?
So our suggestion for improvement is to explicitly position those internal controls as mechanisms specifically for internal isolation and insider mitigation.
Frame them that way.
Yes, and also detail the protocols that secure the audit records after they leave the sandbox post-egress.
Okay, let's look at the mechanisms already in place, just maybe reframing them slightly.
Good idea.
Ensure that the function of the whitelist-based targeting is clearly documented not just as preventing external targeting, which the air gap handles anyway, but as a definitive guard against insider misuse.
Yes. Emphasize that this feature stops a trusted operator from pointing the Achilles engine at, say, unauthorized internal infrastructure or other systems within the environment that aren't approved targets.
So it becomes an internal segregation control, a compliance check.
Exactly. a critical one in this context.
Okay, and let's talk about the secure egress process. The data gets written to write once, read many optical media, CDRs. That's a strong choice, speaks volumes about physical data integrity. Tamper-proof once written.
Absolutely. That technological control itself is top-notch. Can't argue with worm media for this.
But
But the documentation needs to detail the protocol for ensuring the tamper-proof nature of the data after it leaves the sandbox environment.
the physical handling of the disk?
Precisely. The physical object, the CDR itself, needs procedural integrity just as much as the data on it needed technological integrity.
So what's the concrete suggestion there?
We suggest explicitly defining a strict, auditable, probably dual custody, secure egress protocol for that physical worm media once it's created.
Dual custody. Okay.
Yeah, something that guarantees the chain of custody, the audit trail, remains completely intact during transit to wherever the external receiving system is. You've locked down the tech. Now lock down the procedure and the human element around that physical artifact.
Okay, that makes perfect sense. So that brings us towards a wrap-up then.
Right.
Look, this is clearly a foundational document. It shows a really profound command of system defense, cutting-edge automation. It's serious work.
Definitely. The high-level opportunities we've identified are really about maximizing its clarity and ensuring those technical claims are supported symmetrically, right, across the board.
So to quickly summarize the actionable steps we've discussed. First, streamline that documentation structure. Consolidate the definitions, get rid of the redundancy, let the reader pivot straight to the advanced stuff like the orchestration using the enhanced tracer core.
Second, enhance the technical specificity, particularly for the Vulkan and Hephaestus modules.
Yeah, introduce those technical mechanisms like exploit encryption using the AIL public key. And detail the specific APR techniques you're leveraging. That makes the closed-loop claim fully credible, technically symmetrically. And finally, formalize that internal threat model explicitly.
Right. Take the safeguards you already have, whitelist-based targeting, the worm media, and frame them clearly as operational or insider mitigation protocols.
Culminating in defining that strict, auditable, dual custody protocol for handling the physical worm media after it's created.
Exactly. Lock down the process.
Okay, I think these revisions will really sharpen the document's focus, significantly enhance the credibility of the automated systems described, and provide, well, pretty bulletproof robustness against those challenging internal threat factors.
Agreed. It's strong work, just needs that final layer of polish and the documentation.
We definitely look forward to seeing the next iteration. And please feel free to submit the revised material back to us for another critique once these high-level revisions have been made.